Hi, this is Miss French, and this is a video about Newton's second law. You should have your notes and a pencil. Please feel free to pause the video and re-watch any section of it so that you take accurate notes. According to Newton's second law of motion, acceleration depends on the object's mass and on the net force acting on the object. So in other words, acceleration equals net force divided by mass. You can also say that force is equal to the mass of an object multiplied by its acceleration. Force equals mass times acceleration. For example, it is easier for a strong adult to push a full shopping cart than for a small child. Why is that? A full cart has a lot of mass, and to make it accelerate, it will need a lot of force. A small child does not have the force or strength to accelerate the shopping cart. Another example is a train wreck. If a train hits another train of equal force and speed, they will both go the same distance and feel the same amount of force. But if the first train is hooked to a second, the single train will go twice the distance of the double train and will feel twice the force. Okay? And if you look at the video at the bottom of the slide, the same would apply for trucks. The truck on the left, the white truck, is going to experience less force than the small red truck. Okay, the small red truck has less mass and therefore will feel a greater force from the white truck. The formula for Newton's second law is F equals ma. You can rearrange the formula to solve for mass or acceleration. Okay, so for mass, you would simply do force divided by acceleration, and for acceleration, you would do force divided by mass. Don't forget to label your answer appropriately. If you're solving for force, then your answer needs to be labeled with newtons. If you're solving for mass, then it needs to be labeled with kilograms. And if you're solving for acceleration, the standard unit would be meters per second squared. Understand that there will be times that you need to convert units. So if your answer is in grams, or if your mass is given in grams, then you would need to convert it to kilograms. Okay, let's try some practice problems. For example, if a 30 kilogram object is accelerating at 9.8 meters per second squared, with what force is it falling? The first thing that you should do is sub in what you know. What is the information given to you? In this case, the mass was 30 kilograms and the acceleration was 9.8 meters per second squared. Next, you want to decide what formula you want to use. Since you're missing force, you would use force equals mass times acceleration. So in this case, you would multiply 30 times 9.8 for an answer of 294 newtons. Let's try another one. What is the acceleration of a 23 kilogram object being moved with a force of 14 newtons? Again, write down what you already know. Mass was 23 kilograms and the force was 14 newtons. The formula that you should use is acceleration equals force divided by mass. Therefore, 14 divided by 23 is going to give you an acceleration of 0.61 meters per second squared. Let's try one more. What is the mass of an object accelerating at 2 meters per second squared by a 16 Newton force? You are given the acceleration of 2 meters per second squared, and you already know the force is 16 newtons. You will use the formula mass equals force divided by acceleration, and therefore you will have 16 divided by 2 for an answer of 8 kilograms. Okay, so the relationship between force, mass, and acceleration is very important for you to understand. How can force and mass change the acceleration of an object? Okay, so for example, when the force is increased, acceleration will also increase. As shown in the picture, if you push on a ball with more force, then it's going to accelerate faster. If you push on a ball with less force, then it will accelerate more slowly. Okay, when mass increases, acceleration will decrease if force is unchanged. So if you kick a bowling ball and you kick a soccer ball, you will notice, assuming that you kicked with the same amount of force, you will notice that the soccer ball goes further and faster. This is because it has a smaller mass than a bowling ball. And finally, when acceleration increases, force will increase, assuming mass is unchanged. And an example for this would be like a bullet. The mass of a bullet has to be accelerated at a high rate in order to produce enough force to be dangerous. Okay, and here's a video to help you review the concepts. It's about 6 minutes long.
That's a novel way of choosing whose turn it is. But whose turn for what? That's impressive. That's really impressive. Working out is obviously easy in a weightless environment. Let's see you try that on Earth. Not so easy, but I guess that's the difference between mass and weight. You might think this has something to do with weight. Well, you're nearly right. Not just weight though, but mass. Mass is the amount of matter in an object. Weight, however, the feeling of something being light or heavy, is caused by gravity acting on the object. Pedro and Alexander are floating in the ISS. Because gravity has no effect, they feel weightless, even though their mass is the same as it is on Earth. You can see Pedro lifting another astronaut, Umberto Guidoni, here on Earth. Umberto's mass is not that much different to Alexander's, but because he's on Earth, what Pedro's feeling is his weight. So, how does mass come into the second law? This science stuff is very serious. One ball is wooden and the other is brass. This time we have 3 balls. We're adding a ping pong ball. You can see here that things with more mass move more slowly. The second law says there's a connection between force, mass, and acceleration. So, if you apply the same force to objects of different mass, they will accelerate differently. Exotic, a stream with a steady current. There's 1 floater versus 5. I wonder who's going to win. Less mass means more speed. He's way faster. A force is applied, and according to the first law, she should accelerate. Okay, we add a heavy bag, and she seems slower, plus she hasn't travelled as far. This is just like the ISS experiment. That's not a fair race, guys. Here we have magnets set up to repel each other. Magnetism is a force, isn't it? It looks like the skate carrying the load is travelling slower, and that makes sense. More mass means less velocity when the same force is applied. So, Newton's second law states that force is proportional to mass and acceleration. So the greater the mass, the slower an object will accelerate when the same force is applied. Pedro blows the balls with the same breath, but their different masses mean they move at different speeds. Newton's second law is easier to demonstrate on the ISS, but here on Earth there are other factors to complicate things. You might be thinking that the single one will land first. In the other experiments, the lighter object travelled faster, but they landed exactly the same time. We've got a crumpled page and a regular page. They've got the same mass and they're dropped from the same height, so they should land at the same time, right? But no. One of these factors is friction. Friction is the resistance between surfaces as objects move against each other. It causes objects to slow down or stop. If there was no friction, they would keep going. This complicates proofs of Newton's laws, especially because different surfaces create different types of friction. This is why we skate faster on the ice or in a smooth corridor. So, what about the papers? Was there friction acting there? Well, there was friction between the objects and the air. It was due to friction that the flat page landed after the crumpled page. The flat paper has a greater surface area and is slowed down because it experiences more air resistance. If this experiment were conducted in a vacuum, the two pages would land at the same time. But why did the sack of apples land at the same time as the single apple? Well, that's down to a unique feature of gravity. The sack of apples with a greater mass and the single apple with less mass are both attracted by Earth's gravity. But gravity pulls more on the sack of apples than on the single apple. But if something has a greater mass, it needs a greater force to accelerate, right? So that, in the end, both have the same acceleration and hit the ground at the same time.
Okay, don't forget to take my poll on my class website to get credit for watching this video. Thank you.